Okay, here we go. Because the other classes out, I actually had 48 answers up there.
Yeah, I only have 41, so.
Well, that's still probably an A. Okay, you know what that word right there means, don't you? Your favorite subject in math? Fractions. Okay, rational functions. Well, this just means if you have one number over the another number, it's that. Now, don't write this down, okay? Why they're calling this a rational function is because that means it has an expression over an expression. This just stands for one expression, and this stands for the other expression. And you put the one over the other one, and then that gives you your function. Okay. Now they do put a disclaimer on it that whatever is in the denominator can't be zero, because then it would be undefined. And if it is zero, then it's not part of the domain. And that's something we'll talk about in a moment. Okay. Now, if you want to find the domain of a question, the domain, you know that zero products rule that I taught you right at the end last week or earlier this week, where you set it equal to 0 and solve for it? That's how you determine the domain. You factor the denominator, use the zero products rule, and any numbers you get are numbers that can't be part of the answer set, because those numbers would give you a 0 in the denominator. Okay, that's what this is alluding to. In other words, the domain is everything except those when you set the denominator equal to 0 and get answers. Okay, in this case, determine the function values if they exist. Now we got a real number up there, so it's a non-entity. But we're going to look at this expression x minus 3. If we substitute x with 0, then we get a real number. We're good. If we set it equal to 1, we still get a number. We get -2. We set it equal to 2, then we get -1 for the answer, -0.5 for the answer, -0.1 for the answer. But here we would get 0 for the answer. You see that? So therefore, on this equation, 3 cannot be part of the domain. Now, how could you express that? There are two ways you could express it. You could express it in set notation. Okay, the domain equals the set of x values such that x is not 3. Okay. Or you could simply say the domain is the set of values so that infinity, -infinity to 3, that's got to be a parentheses, inclusive of the 3. Nope, not inclusive of the 3, because it can't be the 3. It can't be that, so I have to use parentheses. And from 3 to positive infinity. Now, what is that? What are those two statements saying? If I had a number line, and this number line listed all of the possible values of x that you could substitute into this question and get a real y value, okay, then that's saying that any of them except 3 is the only one you can't have. Graph-wise, it would look like everything here, everything there, like so. Okay, everything except 3. Okay, now here's just doing the work that we mentally did. Okay. You see here, you substitute that in there, you actually get a real number. You substitute the 3 in there, you get an undefined number. Any of those others, you get real numbers. Okay. So the domain of this, which I've already told you, there's the graph of the domain. And it's nice to put that in there. I would use the double R, double stem R. And then I would also, you would have to have this or that. And this is the default for this class. Although Alex, it may not be. Okay, here's another problem. What values of this can it not be? That's basically what this question is asking. Okay, well, it can't be -6. Okay, it can be anything but -6. Now, it's okay to have a 0 on top, but just not on bottom. So we really don't have to do a whole lot of work on this thing. Just look at it and see what it can't be. What would give you a 0 there? Okay, most of the time, it's that simple. You don't actually have to write down doing the 0 products rule. Okay, well, so right here in this case, H is the correct answer on this. Now, write the domain in set builder notation. The set of x values such that x is not -6. X is contained in the set of reals. Kind of a C with an E bar in the middle of it means contains. Okay, what about for interval notation? -infinity to -6, non-inclusive because it can't be union with -6 to positive infinity. So that would be the answer here. Okay. Question on it? Yes.
So we start off with it, you have the x, all the x's equal 0, is that continue on with it? Or
I don't understand your question.
I'm a little confused on when you start off with the.
Well, I didn't show the work on this. What you do, according to those steps on the previous slides, is you take the denominator, that, and then you see what numbers would cause you to get a 0 there. Okay. So the only number in this case that gives you a 0 would be -6. Because -6 and +6 are 0. Yes.
Will these, you always want us to graph them as well?
If it asks you, if it asks you. Now, can you, if it doesn't ask you? Sure. What does the graph of this one look like? There's 0, here's -6. It's gonna look like this and this. That's a parentheses, not a brackets. Okay. Are you okay on this one now?
Yeah,
Okay.
I kind of understand the steps mentioned earlier.
Uh-oh. Now they've thrown a new quirk at us. We can't just look at this and tell what it is. So we've got to do, what we got to do using those steps then is we take this 2x squared minus 11x plus 5 equals 0. Now, this thing we need to see if we can factor it. Well, this one will probably factor into 2x something here, 1x something there. Looking at the rule of signs, they're both minuses, right? Now, we just got to figure out which one of these two the 5 goes with, because it matters. Well, in this case, we're going to have to get an 11. We're going to have the 2 and the 5 opposite. So we're going to have an arrangement like this. Okay. Here I get 10 plus 1 makes 11 because that has to be close. So in this case, the 5 goes there and the 1 goes here. Now, equals 0. So we take the 2x minus 1 equals 0. And we take the x minus 5 equals 0. Plus 1 plus 1. 2x equals 1. Divide by 2, divide by 2. X equals 1/2. That means we can't use x as 1/2 in this problem. Now, here plus 5 plus 5, so x equals 5. So we also cannot use 5. So these are the two values we cannot use. Now, to answer their question the way they want it, it says in set builder and in interval. So for set builder, I would have to say the set of x values such that x is not 1/2, comma, x is not 5, comma, x is contained in the set of real numbers. Okay? And I probably am not going to take off if we forget this, but try to remember it. For interval notation, we're going to start at -infinity, and we're going to go, if we look at this thing in a graph, here's 0, here's 1/2, and somewhere out here is 5. Okay, so we've got this, we've got this, and we've got this. Okay, we got a gap at 1/2. We got a gap at 5, is what this is showing. So we start over here at -infinity and we come up to 1/2. There's how we show our gaps. And then we've got between 1/2 and 5, we've got them there. And then another gap And then we've got from 5 on. Okay. Well, they actually worked this one down for me. So, you can see they factored it like I did, except I put in more detail. So that's basically what I wrote. And that's what I wrote. Here's another one. Okay, so we need to factor that thing. That one won't factor. But we can't call it prime because we got to work it. So we have to use the property of square roots, which I showed you one day. So I've got x squared plus 4 equals 0. Minus 4, x squared equals -4. Then I take the square root of both sides to get rid of that square, plus or minus. Uh-oh. Uh-oh. What am I going to have? I'm going to have an imaginary number. I'm going to have an imaginary number. Anytime you have a negative square root, it gives you an imaginary number. Okay? Well, the square root of 4 is 2. And we got a plus or minus of them. And then that square root of -1 gives you I. Okay? Which stands for imaginary. So these are the two values that it can't be. Well, guess what? They're already imaginary. So they can't be anyhow, because you can't graph imaginaries. So how do we put down our answer on this one? So basically, this is saying any real number. Any real number will work because those are non-real numbers that I saw. Now, here's a fallacy in this program. They expect you to know imaginaries before I taught imaginaries too. Okay. Or did I in this class? I didn't think so. I have in college algebra, but not in this class. There's so much overlap between material in this one and the other one. Sometimes it's hard to remember which one I taught, which one I haven't, to which hour, so to speak. Okay, well, anyway, that thing right there can't factor. So basically, it's any real number because the unreal numbers are already eliminated. What is the interval? Again, any real number. This one, this factors into that. So this becomes -1/2. That becomes +1. So those are the two values that it can't be on this one. Okay. What about this one? Would -1 work? Would -1 work? -1 would get squared to 1, so it would work. Would positive one work? Yeah, it would obviously. Is there any number that won't work with you squaring it? No. So infinity to infinity. Again. Actually, this one does a little bit better job of explaining that idea than the previous one does. Okay, don't write any of this down. All this is saying is if you've got something, if you multiply and divide by the same thing, it's not going to change it. R divided by R is 1. Doesn't matter if you multiply by 1. Okay? So it's saying you can do that. As long as P and R are not 0, so you get undefined. Okay, what about this one? We need to factor the numerator and factor the denominator separately. Now we are doing what we are calling simplifying. We're not just doing the domain, but we still need to do the domain. Okay? Now, let's go ahead and factor these. We can factor a 2x out of everything in the top one, and we can factor a 6 out of everything in the bottom one. By the way, what can you not have in this problem for an answer? -4. Cannot have -4 for an answer in this problem. If you get it, you have to throw it out. Okay? Now, this piece, they factored into those two. Okay? So, is there anything we can cancel now? The x plus 4. So we do that. And I want to go back. That goes one time, that goes one time. So I've got 2x times x plus 2 over 6. The 2 and the 6 can cancel. That'll be a 3, that'll be a 1. So this simplifies to x times x plus 2 over 3, or 1/3 x times x plus 2. Okay. You can manipulate that thing that way.
Alex, the one second, just, for the first way the x.
Now, for the denominator, what they're doing right here is they're saying that x can't be -4. They're doing a domain check. If they ask for restrictions, that's the same as asking for a domain check. Okay? Can't be -4 because that would put a 0 in the denominator. Okay? Now, let's finish simplifying. They've got that. They're getting ready to break it down. They're doing the same cancellations I did. And if you look right here, x plus 2 over 3 is what I've got right here. They did not go ahead and take it this far, and that's fine. Don't have to.
Could you go back to what we did?
The domain,
Yeah.
well, they had already factored a 6 out of it. Right? X plus 4 equals 0, x minus 4, x equals -4, so it can't be -4. Okay, same kind of problem. Factor numerator and denominator. determine any restrictions on x from the denominator, then simplify it as far as you can. Now, I have some rules for rationals on one of my handouts in here. It's a handwritten sheet, and it's not even my writing.
Um,
11. Yeah. Now, those, except for the last two, don't apply to this. Okay? Where it says find LCD, that's when you add or subtract them. Right now, all we're doing is multiplying and dividing. So right now, only step 5 and step 6 of this apply for the moment. Now, that said, let's go through these steps. What are your steps you're going to do? You're going to factor the numerator, factor the denominator. You're going to cancel what you can, simplify what's left. That's your process. And then you also check the domain. So let's go through these steps on this problem. X squared plus 3x minus 28. Okay, 1, 1. And I'm going to be subtracting down here. So, and I want to end up with 3. So how about 4 times 7? Okay, gives me a 7, gives me a 4, subtract them, I get a 3. That's a plus, that's the plus, so here's the plus, there's the minus. So this thing then factors into x plus 7, x minus 4. Okay. Over 2 times x plus 7. Now I can look at this right now and I can make the statement, x is not negative 7. Okay, you with me on that? If this equals 0, then x would be negative 7, which you can't use. Okay, so now I have stuff I can cancel. I can cancel this and I can cancel that. So all I got left now is x minus 4 over 2. Okay, and we can leave it that way, or we can change it to 1/2 x minus 2, like that instead. Okay. So in this case, all it's doing is asking us to simplify. Notice it didn't say equals 0 on the end. So this is really as far as we can go. One of these two answers right here. Either this one or that one. Are you starting to see why I spent so much time on factoring?
Yeah.
Because it's the gateway to pretty much everything we do now. Oh, now we don't have to factor in expression. There aren't any pluses, minuses in this. So this is just straight up and down stuff. So we look at this thing. Now, I'm going to show you how I would do it. They're probably going to show you a little more complicated. Okay, the way I would do this one is I would say 2 goes into 2 once, 2 goes into 8 4 times. Okay. Then I would look at my x's. I've got 2 of them here. I've got 4 of them there. These 2 go away, and this leaves me with x to the second. Now I look at my y's. I got 8 of them here, 3 of them here. All 3 of these go away, and that uses up 3 of these, so I got y to the 5th. Okay? So what do I end up with in this problem? I have 1 times 1 times y to the 5th over 4 times x squared. Done. Okay. Now, is that especially hard? Okay, now, like I said, they're probably going to make it a little more difficult than I did. What did they do? They factored out the common factor.
No, they
didn't
the
either.
2 to the third.
Yeah.
For 8 instead of.
Here's the greatest common factor, actually. That is. And they factored it out and canceled it, leaving that. Well, I think that took more effort than just doing these one variable at a time. I mean, you can do it either way you want to do it. Okay, here's another one. They're not going to work this one, so I get 2. Get 2, right? A to the 5th, B to the 3rd, over 18, A to the 8th, B to the 1st. It's helpful to put those hidden powers in there. Okay, 9 goes once, 18 twice. Considering the A's, I'm going to use up all 5 of these, and I've got A to the 3rd left. For the B's, I'm going to use up this one, and I'll have B to the 2nd left. So my answer then is B squared over 2A cubed. Okay, we're a little more difficult this time. Now we got pluses and minuses we got to worry about. In terms of the numerator, perfect cube on the top and the front, perfect cube on the back. 2 times 2 times 2. So that factors into t plus 2 times t squared minus 2t plus 4, or in other words, 2 squared. 2 squared. Okay. Over things on the way. Okay, this thing will factor into t plus 2, t plus 2. Okay. That being done, this can factor, leaving that over this, t squared minus 2t plus 4 over t plus 2, and that's as far as you can go. At least so far. Later on, we'll go farther. Oh. Okay. Well, almost overlays, doesn't it? Except I spread these out. That spreading them out makes it better for canceling purposes, I think. Now they get around to doing their canceling. So you end up with that. Once again, I review, what is our process? What is our repetitive process? Factor the numerator, factor the denominator, cancel whatever you can, simplify whatever is left. Okay, it's a repetitive four-step process. Making up words now. Okay, what about this one? We got another perfect cube. 27 is 3 to the third. So this problem's almost like the last one. So I've got p minus 3, p squared plus 3p plus 9 over p squared. Oh, I can factor that. That factors into p minus 3, p minus 3. Okay. Well, we can do some canceling. Those two. So p squared plus 3p plus 9 over p minus 3. Oops, a little too soon. Okay, there's something different in this one. I've got the number and the variable reversed sign-wise. Instead of an x squared minus 25, I've got 25 minus x squared. This is still a conjugate, even though it's backwards in order. Okay. This thing still is 5 minus x, 5 plus x. Okay. This is just x minus 5. Now, that's not the same as this. So I can't cancel that just like it is. Correct. Now, does it matter which order this one's in? No. No. I can put it that way, or I can leave it 5 plus x. It doesn't matter on that one. Just matters on the ones where you got the minuses. Okay, this cancels, that cancels. So I've got 1 over negative 1 times x plus 5. Now, I would probably just rewrite this as simply negative 1 over x plus 5. That would be probably my simplest possible answer. Okay. Don't zone out. Okay. Well, there's the answer. They stuck the negative 1 at the back end. I wouldn't. Okay, there we go. Okay, what about this one? I factored a negative 5 out of this, so it left me negative 5 times x minus 4. I factored that into x plus 3, x minus 4. The x minus 4s will cancel. So I've got -5 over x plus 3. Sure. Multiplication and division of them. Okay, we got some disclaimers, okay? And it's just telling you some of these can't be 0. The way they're going to use them. Notice the ones they say can't be 0 are the ones that are in the denominator. Okay. Well, that's just simply a rule. You know, if I take this times RS, then I get PR and QS. Numerator times numerator, denominator times denominator is all this the same. Now, step 1, back to the numerator and denominator. That sounds familiar, doesn't it? Cancel any common factors, including -1s if you have to. Multiply out what's left. Well, haven't we already been doing that? Really? Okay. So here we got 2 problems, 2 expressions to multiply times each other. Here are our steps. Factor, cancel like terms, multiply what's left. Now, when it's multiplication and division, any numerator can be canceled by any denominator. When it's multiplication and division. So that factors into this, that factors into this, and they factored 10. I don't know that I would have, but it's okay that they did. I would have probably left it 10 and then canceled 5 out of both of them, still having 2 left. Okay, now they're going to cancel these 5s. All this, the only difference in this one and this one is they just put it under 1 fraction mark. Okay, I'd probably go straight from this to that. Now, they're going to cancel the 5s. They're going to cancel the A minus B's. They're going to cancel the 2s. So all they got left is 1s over A plus B. That's it. Sure. You asking me to move?
No, she was asking.
No, it's, I was asking if we can hold on a second.
That's what I'm doing that. You're like, oh,
Okay.
Okay, here's, this one's getting a little more complicated. I'd be sure and write this one down. Okay, so the first term, I've got 3 times y minus 2. And this one gives me y plus 2 times y plus 1 when I factor it. Here I've got 6y. This gives me y minus 2, y minus plus 2. Like so. Okay. Anyone have any problems with anything I did so far? Okay. Now we're ready to cancel where we can. Well, this 3 and this 6 will cancel. Y minus 2 will cancel. Y plus 2 will cancel. And it looks like all I've got left is y plus 1 on top over
1.
2, 1. Done. Again, there are your steps. Looking nastier and nastier, aren't they? What? But how are we going to approach this one? We're going to factor the numerators, factor the denominators, cancel what we can, and multiply out, simplify whatever's left over. Okay. Well, if I look at that first one, I can take a 4 out of that, leaving W minus 5P. Over here, that thing, I don't know what it factors into. I've got a 2 and a 1, obviously. My rule of signs tells me I'm going to subtract. Gotta have a 7 when I subtract. So I gotta have something bigger than 7 to start with. So how about I try 5 here and 3 there? That way I get 10 and I can subtract 3 from it and get 7.
Yeah.
Okay. And rule of signs, if this is plus, the biggest is plus, here minus there, or whatever letters in the alphabet it is. P, and oh, that sounded bad. And WW. Okay, so this one becomes 2W minus 3P and W plus 5P. I'm going to erase this scratch work now. Now the denominator. I can take a 2 out of 2. I can take a. I'm going to take a 2 out of this, and I get W squared minus 25P squared, which is a conjugate. So that can be broken down more. And the other one I can take a 3 out of and get W plus 3P like that. Now, so I got to go ahead and break this down further into W minus 5P, W plus 5P times 3 times W plus 3P. Okay, I'm going to just do it that way instead of rewriting the whole thing. Because I'm lazy. That goes once, that goes twice. These two cancel. Okay. Anything else? A W plus 5P. And that's pretty much it, I think. I don't see, this is all I got left up here, and that's all I got left down there. And this and that won't, I forgot my parentheses. And those two won't cancel. So the answer then is 2W minus 3P over
2 times 2W.
3, what?
2 times 2W. We got that 2 from the 4.
Oh, I've still got this 2. So this should be a 4. And, well, no. 2 times that. Okay, and 3 times W plus 3P. So this becomes 4W minus 6p over 3w plus 9p, and that won't break down. What? Just asking me not to erase. And you know what, if you guys want to scratch out a line and show a further factored line underneath it like that, or above it, that's okay. That's okay. Well, here's their work, which is basically the same stuff, except it took them 2 pages. Whoops. And they didn't even finish multiplying this one out.
But that would be factored though, right?
Yeah, that would be factored, so, yeah, I suppose. I wouldn't count either one of those 2 answers wrong. Here's another one. We can do this one or we can keep going. Anyone want to see this one? Speak now or forever hold your peace. I think a preacher said that one time when I was married. I was worried that my wife's brother might actually speak up. He's about ornery enough, yeah. We were married on a Friday afternoon in haying season in Oklahoma, and they were dairy farmers, and a rainstorm was coming. So the minute we said "I do," and he said "I pronounce you," all of the men in the whole church disappeared to go work the fields. I even untied the cans for my car before I drove off. Drove off? Okay, well, anyway. All right, so division property. Okay. Well, the difference is there is a division there instead of a time stop. That makes a big difference with 1 step. Just 1 step different. Look at these rules compared to the ones we've had on all of the one up to this point. I've got 1 extra step in there. Yep.
Right, so with that.
This whole term is called the divisor. Okay. We're going to flip that, but we're going to go ahead and factor it first. Now, does it matter whether you flip first then factor or factor then flip? No, it really doesn't. But it does matter that you do both of those before you try to go here. So in this case, 8t cubed plus 27, that's a perfect cube rule D. That means I'm going to have 2t plus 3 times 4t squared, this term squared. Let's see, that's a plus there, so this has got to be a minus. Now I'm going to have 2t times 3, or in other words, 6t for this term, and then plus that term squared, which is 9. Okay? If I factor this, I'm going to get 3 minus 2t, 3 plus 2t, which I'm going to tell you right now, I'm going to factor a -1 out of that and make this 2t minus 3 and 2t plus 3. Okay? What?
But you wouldn't need to, because you can go ahead and just factor out the 3 plus 2t, because it's the same as 2t plus 3.
Well, yeah, but eventually I'm probably going to want to do this anyway. Okay, the other one. That one factors into, now we got a division sign here. Okay. This factors into, both of them are minuses. So two, probably, let's see, 2, 2, 6. Maybe not factor.
2, 2, 1, 2.
Be careful. 2 and 2, and you're suggesting 3 and 3,
Yeah, it's not great. So,
which would give you 6, which would give you 6, which would give you 12.
right.
Yeah, because we're adding. So that's not a perfect square. Actually, what that is the back end of this. Huh. How about that? Or as they used to say when I was a kid, cowabunga. 4t squared minus 6t plus 9. Now that won't factor. Now this probably will. This will probably factor into 2t here, 1t there. One of these has got to be a plus, and one's got to be a minus, and one's got to be a 3, and one's got to be a 1. So I got a 2 and a 1 there. I'm going to subtract. Okay, I get a 3 and a 1 are my only choices. I need to have a difference of 1. So if I put the 3 here, the 1 there, I get a 3, I get a 2, I subtract them, I get a 1. Rule of signs, that's got to be negative, so the biggest one is negative. So here's my positive, there's my negative, t's rather. So I've got 2t minus 3 and t plus 9 plus 1. I'll erase the scratch. Now I have to flip this business. Okay, so I got negative 1 times 2t minus 3. Oops. I've got 2t plus 3, 4t squared minus 6t plus 9 over negative 1 times 2t minus 3, 2t plus 3, this is getting boring, times 2t minus 3, t plus 1, I better put a tail on that t, over 4t squared minus 6t plus 9. Okay. Now we're ready to cancel where we can. Let's get rid of these two ugly things first. Okay. Then we got anything else? Well, 2t plus 3, 2t plus 3. Here's a 2t minus 3, a 2t minus 3. So we hadn't got a whole lot left. We got 1, 1, 1, t plus 1 over negative 1, 1, 1, 1 over this negative 1. So the answer then is negative 1 times t plus 1, or better yet, negative t plus minus 1. Either one of these two answers. Okay. Okay. That was a pretty hard problem. And it was a long, boring, just copy stuff problem. Okay. I sympathize with you on that. Now, what are previews of coming distractions for you? Distractions from your fun life, if you have a life. Monday, you got a test in here. Okay, if you want to come in a little early so you can finish a little early, like we did last time, that's okay. Your citations are in the course content of Blackboard. Okay, they've actually been there a week, almost a week since Sunday. Any other questions? All right, see you. Have a good weekend. Don't forget to turn in your papers over there if you haven't already.